Ever heard of light shining through walls? Sounds crazy, right?
Yeah, like some kind of superpower?
Well, it kind of is.
Oh.
It's what scientists are trying to do in the search for dark matter.
How so?
Well, you see, dark matter is this invisible stuff.
Invisible.
Yeah, we can't see it or interact with it.
But it's a big deal, right?
Huge. Makes up a giant chunk of the universe.
Okay, I'm starting to see why we'd want to find it.
Exactly. And that's what today's deep dive is all about.
Oh, cool.
We're looking at this fascinating article from the University of Oxford
Okay.
about how scientists are using some seriously powerful tools to try and detect dark matter.
So what are we talking about? Telescopes? Satellite?
Even cooler, a theoretical particle called the axion.
Axion. I've heard of that. Isn't that supposed to solve a bunch of problems in physics?
Two big ones.
Really? Okay, hit me with the first one.
You got it.
Hmm.
It's called the neutron puzzle.
Okay.
Neutrons, you know?
Yeah, made up of quarks, right?
Right, and quarks have an electric charge.
Yeah.
But here's the thing. Neutrons themselves don't seem to have an electric dipole moment.
I think I remember that from physics class. What does that mean again?
Basically, they're perfectly balanced, even though they shouldn't be.
Wait, so how does that work?
Axion to be the key?
How so?
They could be canceling out the imbalance.
Like they're the missing piece of the puzzle.
Exactly. And that brings us to puzzle number 2. Dark matter itself.
Right, right. So axions could actually be dark matter.
That's the leading theory.
Wow, that's huge. If we find axions?
It would be a landmark discovery in cosmology.
Okay, I'm sold. But how are scientists going about finding these axions?
Well, the article mentions something about a giant X-ray laser.
Okay, a laser. For dark matter. How does that even work?
That's where things get really interesting. This research is happening at the European XFEL.
Never heard of it.
Oh, it's amazing. Imagine a 3.4-kilometer long, super-powered X-ray laser.
Whoa, that's massive. 3.4 kilometers.
Yeah, it's mind-boggling, and the sheer power of this thing is insane.
How powerful are we talking?
It can generate X-ray flashes at a rate of, get this, 27,000 per second.
27,000 per second? That's crazy.
Right. That's what makes this type of research possible.
Okay, I'm hooked. Tell me more about how they use this laser to find axions.
It's a technique called light shining through walls.
Light shining through walls. That sounds like pure science fiction.
I know, right? But it's based on some really fascinating physics.
Okay, you got to explain this one.
Think of it like catching a ghost.
Oh, I like that. Okay.
You can't see the ghost directly,
Right.
but you might be able to detect its presence with a special trap.
Okay, I'm following so far.
So in this case, axions are the ghost.
And what's the trap?
They're firing these super-powered X-rays from the XFEL.
Oh, okay, the laser.
Exactly.
Go on.
And they're firing these X-rays through special crystals made of germanium.
Crystals, what do those do?
They create this crazy, intense environment.
Like a force field?
Kinda. It acts like a super strong magnetic field for the particles.
A magnetic field. How strong?
Hundreds of times stronger than anything we can create in a lab.
Wow. Okay, so we have super-powered X-rays
Hitting a crystal.
with an incredibly strong magnetic field.
What happens next?
I don't know. You tell me.
Okay, so under these extreme conditions, something incredible can happen. The
Photons.
those particles of light that make up the X-rays,
Okay.
they can actually convert into axions.
Wait, so light can transform into dark matter?
That's the idea. It's like they're temporarily transforming into these dark matter particles.
That is seriously wild. But if the axions are invisible...
How do they know if the transformation happened?
Exactly.
That's the genius part.
Tell me.
It's the shining through walls part.
Okay, remind me how that worked again.
So after passing through the first crystal,
Yeah?
the X-rays hit an opaque sheet of titanium.
Titanium. What's that for?
It blocks any remaining photons.
So it's like a wall that light can't penetrate.
Exactly. A wall for light, but not for axions.
Oh, I see. So the titanium is like a filter,
Yeah.
only letting the axions through.
Right. Now, if axions were created in that first crystal,
Yeah.
they should pass right through the titanium wall. And on the other side, there's another germanium crystal waiting.
Another crystal.
Yep. Well, what happens when the axions hit that?
That's what they're hoping to find out.
Okay, so walk me through this.
If they detect photons.
But how could there be photons? They were blocked by the titanium.
Right. Unless
Unless what?
the axions converted back into photons when they hit that second crystal.
Whoa. So they're hoping to see light that shouldn't be there.
Exactly.
That's insane.
It would be strong evidence that axions exist.
So are they saying they've actually found them? Well, not quite yet. This initial study was more like a proof of concept.
A proof of concept.
Yeah, showing that this technique with the XL could be a real game changer.
So it's not over.
Definitely not. They're just getting started. The results are promising. So what's the next? What's the plan to actually find these axions?
They want to make the experiment even more sensitive.
How much more sensitive are we talking?
Hundreds of times.
Wow, hundreds of times. Okay, so what would that allow them to do?
Well, it would let them look for axions in a very specific mass range.
Okay, a mass range.
Yeah.
And why is that important?
It's all about quantum chromodynamics.
Quantum chromodynamic. Remind me what that is again?
It's in theory that describes the strong force.
Oh, right, one of the fundamental forces of nature.
Exactly. And this theory predicts that axions should exist within a certain mass range.
So if they detect axions in that range.
It would be a huge piece of evidence that they really exist.
Okay, so we're talking potentially a major discovery here.
Oh, absolutely.
So what would confirming the existence of axions mean for us? For our understanding of the universe?
It would be monumental. Think back to those two mysteries.
The neutron puzzle and dark matter.
Exactly. Finding axions would solve both of them.
That's incredible. But is there more to it than that?
Oh yeah, it goes even deeper.
Deeper? How so?
It means our current understanding of the universe is incomplete.
Whoa. Okay, hold on, you're losing me. What do you mean by incomplete?
Okay, so we have the standard model of particle physics, right?
Right. It describes all the fundamental particles and forces.
Right. And it's been incredibly successful.
One of the most successful theories in physics.
Exactly. But here's the thing. The standard model doesn't include axions.
Oh, I see. So if we find them,
It means we need to expand the standard model.
there's more to the universe than we thought.
Way more. A whole new set of rules governing how galaxies form and behave.
And maybe even how the universe itself evolved.
Potentially, yeah.
That is seriously mind-blowing.
It really is.
It's like discovering a whole new continent, a whole new layer of reality.
A perfect analogy.
This research is amazing, and the scientists involved.
Brilliant minds, for sure.
The article highlights the work of the late Professor Ian Shipsey,
An incredible physicist.
and it mentions all the different areas of expertise that came together.
Yeah, it was a true collaboration.
It really shows you how big breakthroughs happen, right?
Oh, absolutely. Teamwork is essential.
Bringing together different perspectives, different ways of thinking.
Exactly. It's how we push the boundaries of what we know.
And this is just one example of how much more there is to learn about the universe.
It's a vast and mysterious place.
Okay, I have to ask, what about the philosophical implications of all of this? You said earlier that discovering dark matter could change our understanding of reality.
Oh, yeah, that's a big one.
So what did you mean by that?
Well, for one thing, it's incredibly humbling.
Humbling.
Yeah, to think that most of the universe is made up of something we can't even see.
It challenges our perception of what's real.
Exactly.
It's like realizing we've been looking at the universe with blinders on,
A great way to put it.
only seeing a tiny fraction of what's actually out there.
And it makes you wonder, what else are we missing? What other secrets is the universe hiding from us?
This is giving me chills. Are we on the verge of a whole new era of scientific exploration? A new understanding of the universe and our place in it?
I think we are. These are exciting times.
It all started with a simple question. What is this missing mass in the universe?
And that question has led to decades of research, countless experiments.
And now, potentially to the discovery of a whole new particle.
It's incredible.
It really shows you the power of human curiosity.
Our drive to explore the unknown.
So what's next for this research? What are the next steps?
Well, the next step is putting those upgrades to work.
At the XFEL.
Right. Remember boosting sensitivity by hundreds of times.
Yeah, that was a big deal.
If they can pull that off.
They can really start hunting for those axions.
Yeah, within that specific mass range we talked about.
The one predicted by quantum chromodynamics.
Exactly.
So it's a waiting game.
For now. But it's a pretty exciting waiting game, I'd say.
For sure. But, okay, let's say they do find those axions.
In that mass range.
Yeah, what would it mean for us here on Earth? Would it change anything?
That's the million-dollar question, isn't it?
I guess so.
It's tough to say for sure, you know?
What do you mean?
These fundamental discoveries, they don't always have immediate practical applications.
Oh, I see.
But history shows us that advancing our understanding of the universe,
Yeah.
it often leads to some pretty amazing technological innovations.
Oh, yeah, for sure.
It just takes time.
Like electricity
Exactly.
or the internet.
Started as purely scientific endeavors.
And look at them now.
It changed everything.
So who knows what the future holds for axions?
Maybe new technologies, maybe even new industries.
Things we can't even imagine yet.
Right.
So for now, it's all about pushing those boundaries of knowledge.
Seeing where that curiosity leads us.
This whole conversation has been incredible.
I agree.
It's like we've been on this journey through the cosmos,
Exploring the deepest mysteries of the universe.
learning about dark matter and axions.
And these amazing scientists who are trying to find them.
It's truly mind-boggling stuff.
And we've only scratched the surface.
There's always more to discover, isn't there?
Oh, absolutely. That's the beauty of science.
It's a never-ending quest for knowledge.
I love that.
Before we wrap up, though, I
Yeah.
want to circle back to something you mentioned earlier.
What's that?
The possibility of other hidden realities.
Oh, yeah.
It really got me thinking, You know,
What about it?
if most of the universe is made up of dark matter,
Something we can't even see.
right, what else could be out there?
What other secrets is the universe hiding from us?
That's a great question.
It's one that has fascinated people for centuries.
And one we may never have a definitive answer to.
But that's what makes it so exciting, the search for knowledge,
Embracing the unknown.
pushing the limits of our understanding.
Well, this deep dive has certainly been an eye-opener for me.
Me too.
We've learned so much.
About axions and dark matter
And the incredible technology being used in this research.
is cutting-edge stuff
And the potential implications are huge.
for our understanding of the universe.
Maybe even for our place in it.
Exactly.
So what's the big takeaway for our listeners today?
I'd say the biggest takeaway is this. We are living in an extraordinary time.
A time of incredible scientific discovery.
We're on the verge of unlocking some of the universe's biggest secrets.
And who knows what other wonders are out there waiting for us.
It's an exciting time to be alive, that's for sure.
If you're as fascinated by this as we are,
Definitely check out more about dark matter and axions.
and the European XFEL,
It's an incredible facility.
it's a journey of discovery.
And who knows, maybe one of you listening will make the next big breakthrough.
Keep exploring, questioning, and never stop learning.
Couldn't have said it better myself.
Thanks for joining us for this deep dive.
It's been a pleasure.
We'll be back soon with another fascinating topic to explore together.